Okay, 8.4, we're at the last part of chapter 8. We've been talking about trigonometry and how awesome it is. And this last section is called angles of elevation and angles of depression. So by the end of the video, you should know how to solve problems, word problems, using angles of elevation and angles of depression. So the vocab that we need to know today is what is an angle of elevation and an angle of depression. And as this picture shows you, an angle of elevation is one where you're looking up, and an angle of depression is one where you're looking down. But this is really important, so I want you to write it down. The angles must, I don't know why this is being weird, must hit or touch the horizon. And I want you guys to notice that the horizon is the one that's always parallel to the floor. So these are both considered horizons. This one is the horizon for this guy, and this one's the horizon for the guy in the airplane. And they're parallel, which is why I put the parallel marks. So if they're parallel, then that's going to mean that angle 1 is congruent to angle 2 because they're alternate interior angles. Okay, so angle of elevation is above the horizon, and angle of depression is below the horizon. All right, so that'll help you distinguish the difference between angles of elevation and angles of depression. Let's see. So the first thing you're going to do on your homework tonight is to determine whether something is an angle of elevation or an angle of depression. So, for example, for 1 through 4, I'll do this one with you guys. For number 1, angle 1 is, see, this is it has to touch some parallel line. So this is the horizon that it's touching, and it's below. So that means that it's an angle of depression. Angle 2, if you notice, it touches this parallel line, and it's above it. So that means that it's an angle of elevation. Angle 3, still touching this parallel line, same parallel line, but this time it's below it, so that means it's an angle of depression. You want to think about it in terms of the dude, he's looking down, so that's why it's an angle of, another reason why it's an angle of depression. And then the last one, angle 4, if you look at angle 4 is right here, it's touching this line and it's above that line, so it is angle of elevation. You now get to try to do 5 through 8, and I will check this in class. All right. So next, we're going to actually use angles of elevation and angles of depression to solve some problems. First ones are going to be easy because I'm going to give you a picture. I'm going to make it harder as we go and not give you pictures. So for number 9 is find the height of the Space Needle. I definitely changed the question a lot. Again, I'm making it easy for you guys because I'm giving you guys a picture. And this is the Space Needle right here. So I'm going to put y equals the height of the Space Needle, which is pretty cool if you've ever been there in Seattle. Okay, so we want to figure out what this one is. We know that it's 70 degrees angle of elevation, and that's 67 meters, we're 67 meters away. So we're either going to have to use sine, cosine, or tangent. So, ca, toa. And I'll give you a hint. Most of the time we're going to be using tan for these problems, but let's double check. Y is opposite the 70 degrees, and we have an adjacent side. So we are going to use tan. So tan of the angle equals opposite over adjacent. And the opposite of dividing by 67 is multiplying by 67. So literally we put 67 times tan y into our, or tan 70 into our calculator. And that'll give us the height of the Space Needle. So 67 tan 70. I get that the Space Needle is 184 meters, about. Pretty tall. That's a lot of meter sticks. Okay. Number 10, find the distance between the plane and the landing strip. So here's the airport, here's the plane that's in the sky. We're going to work in a second on how to draw these triangles. So we want to know how far apart, when it says find the distance, they're talking about this line right here. How far away is this airplane? If it was on the floor, how far would it have to travel to get to the airport? Okay, so we know we have an opposite side. 3,500 feet is opposite the 29, and x is considered the adjacent. So again, we're going to use tangent of the angle equals opposite over adjacent. Since x is on the bottom this time, That means we're going to swip these two. So we have x equals 3,500 divided by tan 29. So you literally put that into your calculator, 3,500 divided by tan 29. And I get that the airplane has 6,314 more feet to go until it reaches the airport. All right, let's see what else we have to do here today. There we go. Okay, so these ones are going to be a little bit harder because sometimes we have pictures and sometimes we don't. So let's try this one. An ice climber stands at the edge of a crevice that is 115 feet wide. So we have ourselves, we'll be the ice climber here, and it's standing at the edge of a crevice. That's it's like you're at the edge of like a canyon, basically. Okay, and it says that it's 115 feet wide. So I know that this is 115 feet wide. This is important. The angle of depression from the edge where we stand to the bottom of the opposite side is 52 degrees. So what that means is from where I'm standing down to the opposite side, this angle of depression, here's my horizon, right? This is my imaginary line. This depression means it's below the horizon. So that means this angle right here is 52 degrees. Super important. How deep is the crevice? So we want to know how far is it. I'll put X right here. Okay, so if 52 degrees is right here, well, there's two ways you can do it. Since these angles are since these two horizons are parallel, that means that the 52 degrees could be right here. And then you can, so ignore this 52 and put the 52 right here. And now you can use tangent of 52 equals opposite over adjacent. And then the opposite of dividing by 115 is multiplying by 115. So we have 115 times tan 52 equals x. So pop that into your calculator and tell me how far that crevice is. Okay, you're going to try to do number 12. And I will check this in class. And the last type of question I'm going to give you guys is the hardest type of question I could give you. Let's see, how am I doing on time here? Sweet. Okay. Hardest type of question I could give you are these kind of questions. It's where we have to draw two triangles. We have an observer in a lighthouse 69 feet above the water. That's important. Okay, so here's my lighthouse. Yeah, it's a little tilted, sorry. I know it's 69 feet. Okay, 69. This is my lighthouse. And I sight two boats. So here's one boat. There's a boat. And here's another boat. Okay. The angle of depression to the nearest boat is 48 degrees. So if I drew like this, angle of depression, here I am all the way at the top of the lighthouse, right? So here's my invisible horizontal line. And if I look down, the angle of depression right here is 48 degrees. So again, if this is 48 degrees, that means this angle has to be 48 degrees. And I want to know how far away is this first boat. So wouldn't you know it, we're going to use tan again, get rid of this 48 degrees. So we're going to find the first boat, we're going to use tangent of the angle equals opposite, which is 69, over adjacent, which we don't know. And since x is on the bottom, you swip these two. So literally in your calculator, you put 69 divided by tan 48. And that gets us 62 feet. So I know right now that x equals 62 feet. So the first boat is 62 feet away. Okay, so I know that this first boat is 62 feet away. Oops. Okay, 62. That's a 2. Okay, we're not done with this problem though, because now I want to know how far away is the second boat. So I'm going to erase some of this information that we needed for the first problem. So we don't need it anymore. Okay, we figured out the first boat is 62 feet away. Now to find how far away the second boat is, we read the directions again, and this time it says that the angle of elevation is depression is 22 degrees, which makes sense. Since it's farther away, your angle of depression is going to be smaller. So this time we have 22 degrees here, and we want to know how far this is. I'm going to call this y, the distance to the next boat. So if 22 degrees is here, that means 22 degrees is going to be here. And wouldn't you know it, to find the distance of the second boat, you're going to use tan again, but it's tan of 22 degrees this time equals opposite, which is still 69, over the distance, which is y. So you flip them again. So literally you put 69 divided by tan 22, and I get that the second boat is 171 feet away. The question is asking you what's the distance between the two boats. So if one boat is 62 feet away, another boat is 171 feet away, what you have to do is just subtract. And you're going to get that the two boats are about 108 or 109 feet away. Okay, I'm sorry that that took so much space up. I don't know why this pen's being funky today, but your job is to do number 14. I will check this tomorrow. This is definitely the hardest kind of question that I could ask you because it involves two problems, two different can problems, and you also have to draw your picture. So we talked about angle of elevation and angle of depression. Make sure you know what those two things are before you come into class tomorrow. Okay, awesome job. Remind yourself what an angle of elevation and angle of depression are. Thank you. Bye.